You think you know how this story ends? You think you've heard it all before. The universe expanding, cooling, dying a slow, cold death as the last stars flicker out and everything fades to black. But what if I told you that you're wrong? What if the real ending is so much stranger, so much more terrifying and beautiful than anything you've imagined? What if the universe doesn't end with a whimper, but with something that defies every law of physics you thought you understood? Picture this. It's 100 trillion years from now. The sun is gone. Not just dimmed, gone. Every star you've ever seen in the night sky has burned out, collapsed, or been torn apart by the relentless expansion of space itself. The Milky Way has long since merged with Andromeda, and even that cosmic dance has ended. Galaxies have drifted so far apart that if you could somehow still exist, you'd see nothing but darkness in every direction. No light, no heat, no energy flowing anywhere in the observable universe. This is what physicists call the heat death. The final chapter where entropy wins and everything reaches perfect, deadly equilibrium. But here's where your assumptions crumble. Here's where the universe reveals its most haunting secret. Even in this cosmic graveyard, something survives. Something that should not exist. According to everything we know about physics. Something that grows stronger as everything else withers away. You see, scattered throughout this dead universe like ancient monuments in a forgotten cemetery. Black holes continue to exist. Not just exist. They thrive. They become the universe's last heartbeat, its final breath, its ultimate rulers, in a realm where time itself begins to lose meaning. Now, you might think you understand black holes. You've seen the pictures, the computer simulations, the way they bend light around them like cosmic funhouse mirrors. But you don't really know what they are. You don't understand the paradox they represent, because black holes aren't just objects. They're wounds in reality itself. Places where the universe breaks down and admits it doesn't know its own rules. They're regions where time slows to a crawl, where space curves so violently that it tears itself apart, where the very concept of inside and outside becomes meaningless. And here's the part that will keep you awake at night. These cosmic monsters might be the key to understanding whether anything at all, can survive the ultimate death of everything. Because while every star dies, and every planet crumbles, and every atom eventually decays, black holes seem to operate by different rules entirely. They exist in a state that's neither fully alive nor completely dead, neither entirely real nor completely abstract. They're the universe's way of asking a question with no answer. What happens when you take the concept of forever and push it beyond its breaking point? But before you can understand how black holes might outlast the universe itself, you need to grasp something that will fundamentally change how you see reality. Everything you think you know about time, space, and existence is about to be turned inside out. Because the story of whether black holes survive the end of the universe isn't just about physics. It's about the nature of existence itself. It's about whether nothing can ever truly be nothing, or whether the universe has one final, impossible trick up its sleeve. The answer lies in a discovery that has left physicists questioning everything they thought they knew about the cosmos. It's a discovery that suggests the universe might not die the way we expect. It suggests that black holes, these seemingly destructive forces, might actually be the universe's way of preserving itself, not preserving matter, not energy, not even information, as we understand it, but preserving something far more fundamental, something that exists in the strange borderland, between physics and philosophy, between what we can measure and what we can only imagine. You see, when Stephen Hawking first suggested that black holes could evaporate, he thought he was describing their death. But what he actually discovered was far more profound. He discovered that black holes don't just bend space and time, they bend the very concept of existence itself. They exist in a state that's neither alive nor dead, neither permanent nor temporary. They're the universe's way of asking, what does it mean for something to end when time itself stops making sense? This isn't just about physics anymore. This is about the fundamental nature of reality, about whether the universe has a purpose, about whether consciousness itself might be more than just a temporary arrangement of atoms. Because if black holes can survive the end of everything, if they can exist in a state beyond time and space, as we understand them, then maybe, just maybe, they're not the end of the story. Maybe they're the beginning of something else entirely. Something that we don't have words for yet. Something that makes the death of the universe not an ending, but a transformation into something so alien, so impossible, that it challenges every assumption we've ever made about what it means to exist. The universe is about to reveal its deepest secret. Are you ready to have everything you believe about reality turned upside down to understand why black holes might be the universe's final survivors? You first need to understand what the universe actually is, and more importantly, what it isn't. Everything you think you know about the cosmos is built on a foundation that's far more fragile than you realize. Because the universe isn't just a collection of stars and planets, scattered through empty space. It's something far stranger, far more alive, and far more temporary than anyone wants to admit. Imagine, if you will, that the universe is like a soap bubble, floating in an infinite void. But this isn't just any bubble. It's a bubble made of space and time themselves, expanding outward at an ever-increasing rate, stretching thinner and thinner with each passing moment. The surface of this bubble is everything that exists. Every galaxy, every star, every atom, every thought you've ever had. And just like a soap bubble, it's beautiful, iridescent, and absolutely doomed to pop. This is the reality we live in. The universe began 13.8 billion years ago, not with an explosion in space, but as an explosion of space itself. Picture this. In the beginning, there was no where for anything to happen, no when for events to unfold. Then, in an instant so brief it defies human comprehension, space and time burst into existence and began expanding, faster than the speed of light. This wasn't matter flying apart through empty space. This was space itself being born, stretching, creating room for matter to exist in the first place. But here's where the story gets unsettling. That expansion never stopped. In fact, it's accelerating. Right now, as you sit here, space is growing between every atom in your body, between every star in the galaxy, between every galaxy in the observable universe. The fabric of reality itself is being stretched like taffy, and the stretching is getting faster every single second. Scientists call this dark energy, but that's just a name for something we don't understand. A mysterious force that seems to be tearing the universe apart from the inside out. Now, you might think that gravity would eventually win, that all this matter would pull itself back together into a cosmic collapse. But the universe had other plans. As space expands, it carries galaxies away from each other at incredible speeds. The most distant galaxies are already racing away from us faster than light itself, disappearing beyond an event horizon that we will never be able to cross. They're not just moving away, they're being erased from our reality, fading into a darkness so complete that it's as if they never existed at all. This is the cosmic stage on which our story unfolds, a universe that's not just expanding, but accelerating its own destruction, stretching itself into oblivion, while carrying everything we know and love along for the ride. But even this mind-bending reality isn't the full picture, because woven throughout this expanding tapestry of space and time are objects so strange, so impossible, that they seem to exist outside the normal rules of physics altogether. These are the black holes. Regions where the universe's expansion comes to a grinding halt, where time itself slows to a crawl, where the very concept of here and there becomes meaningless. They're not just objects in space, they're wounds in the fabric of reality, places where the universe folds in on itself so completely that it disappears from our understanding of what's possible. To truly grasp what a black hole is, you need to abandon everything you think you know about objects. A black hole isn't made of matter in any sense we can comprehend. It's made of collapsed space itself, crushed down to a point where the normal laws of physics simply give up and walk away. At its heart lies something called a singularity, a point of infinite density, where the very concept of point breaks down. It's not a place you could visit, because there's no there. There. It's not an object you could measure, because measurement itself becomes meaningless. It's a mathematical impossibility that somehow manages to exist in our supposedly rational universe. And surrounding this impossibility is the event horizon, a boundary in space beyond which nothing, not even light, can escape. But here's the part that will twist your mind. The event horizon isn't a physical surface. It's not made of anything. It's simply the point where the curvature of space-time becomes so extreme that the universe essentially says, "No further." Cross that line, and you don't just die, you cease to exist. In any meaningful sense, you become part of something that exists outside time, outside space, outside the very concept of existence itself. But black holes don't just exist in isolation. They're connected to the universe's expansion in ways that are deeply unsettling as space expands and the universe grows colder and darker. Black holes remain unchanged, like ancient monuments, in a landscape that's constantly shifting around them. They're not carried along by the expansion. They're anchored to something deeper, something that exists beneath the surface of reality itself. And here's where the cosmic setup becomes truly disturbing. While the universe expands and cools, while stars burn out and galaxies drift apart, black holes are actually growing. They're feeding on the cosmic microwave background radiation, the leftover heat from the Big Bang itself. They're swallowing dark matter, dark energy, and anything else that comes too close. They're becoming more massive, more powerful, more deeply embedded in the structure of space-time with each passing eon. This creates a paradox that strikes at the heart of everything we think we know about the universe. If the universe is expanding and cooling toward a heat death, where nothing can survive, how can black holes continue to grow stronger? If entropy always increases, and energy always flows from hot to cold, until everything reaches equilibrium, how can these cosmic monsters maintain their grip on reality for trillions upon trillions of years? The answer lies in a discovery that has fundamentally changed how we understand the relationship between time, space, and existence itself. It's a discovery that suggests the universe might not be heading toward the simple heat death we've always assumed. Instead, it might be heading toward something far stranger. A state where the normal rules of physics break down completely, where the very concept of ending becomes meaningless, where black holes transform from destroyers into something else entirely. Because here's the secret that cosmologists are only beginning to understand. The universe isn't just expanding, it's evolving. It's changing not just in size, but in its fundamental nature. The laws of physics that govern our current reality might not be permanent. They might be temporary features of a universe that's still learning what it wants to become. And black holes, these impossible objects that exist at the intersection of known and unknown physics, might be the key to understanding what comes. Next, the stage is set. The universe is racing toward its own destruction, carrying everything we know into an endless, cold darkness. But scattered throughout this cosmic tragedy are objects that refuse to follow the rules, that exist in a state beyond life and death, beyond time and space as we understand them. The question isn't whether black holes will survive the end of the universe. The question is, might they be the universe's way of ensuring that the end is never really the end at all? The first person to truly understand what black holes might become was a man who never intended to revolutionize our understanding of the universe. His name was Carl Schwarzschild, a German physicist and astronomer, who, in 1916, was serving as a soldier on the Russian front during World War I, just months after Einstein published his theory of general relativity. Schwarzschild solved Einstein's equations for the spacetime around a massive, spherically symmetric object. What he discovered was so disturbing that Einstein himself refused to believe it could exist in nature. Schwarzschild's solution revealed something mind-shattering. If you compressed enough mass into a small enough space, you would create a region where the curvature of space-time becomes infinite. Not just very large, infinite at this point, called a singularity. The very fabric of reality breaks down. Space and time lose their meaning. The laws of physics simply stop working. It's as if the universe encounters a mathematical expression that divides by zero and responds by having an existential crisis. But here's where the story becomes truly haunting. Schwarzschild died of an autoimmune disease on the Russian front just months after making his discovery, never knowing that he had glimpsed the universe's deepest secret. His equations survived him, describing objects so strange they wouldn't be taken seriously for another 50 years. Objects that exist in a state that's neither alive nor dead, neither real nor imaginary. Objects that are, in the most literal sense, holes in the fabric of existence itself. To understand what Schwarzschild discovered, imagine reality as a vast, smooth sheet, stretched tight in all directions. This sheet represents space-time, the four-dimensional fabric that Einstein revealed underlies all of existence. Now imagine placing a bowling ball in the center of this sheet. The weight of the ball creates a depression, a curvature, that affects how everything else moves across the surface. A marble rolled across the sheet will follow a curved path around the depression, just as planets orbit the Sun by following the curvature of space-time, created by the Sun's mass. But what happens if you keep adding more and more mass to that bowling ball? What happens if you compress it down to an infinitely small point, while keeping all of its mass? The depression becomes deeper, the curvature more and more extreme, until something impossible happens. The sheet doesn't just bend, it tears. It creates a hole that goes all the way through, connecting our reality to what? Another dimension? Another universe? Pure nothingness? The mathematics can't tell us, because, at the singularity, mathematics itself breaks down. This is what lies at the heart of every black hole, a point where the universe admits it doesn't know its own rules, but surrounding this mathematical impossibility is something even stranger: the event horizon. Picture the event horizon as the point of no return, the ultimate boundary between the known and the unknowable. It's not a physical surface. It's more like the mathematical edge of existence itself. Cross this boundary, and you don't just die, you cease to exist in any meaningful sense within our universe. But here's where the story takes a turn that will reshape everything you think you know about time and space. According to Einstein's theory, time isn't constant. It flows differently, depending on how fast you're moving and how strong the gravitational field is around you. Near a black hole, where gravity is so intense that it warps space-time beyond recognition, time begins to behave in ways that defy human intuition. Imagine you're watching a friend fall toward a black hole. As they approach the event horizon, something extraordinary happens. From your perspective, watching from a safe distance, time begins to slow down for your friend. Their movements become sluggish, their words drawn out, their entire existence stretched like taffy. As they reach the event horizon, they appear to freeze completely. Their image redshifted into invisibility as time dilation approaches infinity. From your perspective, they never actually cross the event horizon. They become a frozen fossil on its surface, preserved forever in a single moment of time. But from your friend's perspective, something entirely different happens. They continue falling, cross the event horizon without noticing anything special, and continue toward the singularity, where they're eventually torn apart by tidal forces. Their experience is finite, lasting only minutes or hours. Your experience is infinite. You see them frozen at the event horizon for the rest of eternity. This is the paradox that lies at the heart of black hole physics. Two equally valid perspectives that completely contradict each other. Which one is real? The answer is both and neither. Reality itself becomes relative, dependent on where you stand and how you're moving. This isn't just a quirk of physics, it's a fundamental feature of the universe. Truth, it turns out, is not absolute. It's contextual fluid and ultimately unknowable in any complete sense. Now, let's take this impossibility and push it even further. What happens inside a black hole? What exists beyond the event horizon in that region where causality breaks down and the normal flow of time ceases to have meaning? The honest answer is we don't know, and in a very real sense, we can't know. But the mathematics suggests something so strange that it challenges every assumption we've ever made about the nature of reality. Inside a black hole, the roles of space and time become reversed. The radial direction, the direction toward the singularity, becomes time-like, while time itself becomes space-like. This means that falling toward the singularity isn't like moving through space. It's like moving through time. You're not traveling to a place. You're traveling to a when, and that when is the moment when space and time themselves cease to exist. But even this description is inadequate because it assumes that concepts like inside and outside have meaning when applied to a black hole. They don't. A black hole isn't a place you can visit. It's a state of existence that's fundamentally different from anything we can comprehend. It's not empty space. It's the absence of space itself. It's not a region of time. It's the place where time goes to die. And yet, impossibly, black holes do exist. We've seen them, measured them, watched them devour matter and energy, with an appetite that seems to grow stronger with each meal. They're scattered throughout the universe like ancient monuments to the breakdown of physical law. Reminders that reality is far stranger and far more fragile than we want to admit. The Milky Way galaxy alone contains an estimated 100 million black holes, ranging from stellar mass objects, just a few times heavier than the Sun, to supermassive monsters containing billions of solar masses. At the center of our galaxy lurks Sagittarius A, a supermassive black hole, with a mass 4 million times greater than our Sun. It sits there in the darkness, invisible and patient, occasionally flaring to life when some unfortunate star wanders too close to its event horizon. But here's the most unsettling part. These cosmic monsters aren't just passive observers of the universe's expansion. They're active participants, growing stronger, as everything else grows weaker, as the universe expands and cools, as stars burn out, and galaxies drift apart. Black holes continue to feast on the cosmic microwave background radiation, the leftover heat from the Big Bang itself. They're not just surviving the universe's journey toward heat death, they're thriving in it. This creates a cosmic hierarchy that will define the far future of the universe. As ordinary matter becomes increasingly rare and dilute, black holes will become the dominant form of mass energy in the cosmos. They'll be the last objects capable of doing work, the last sources of energy, the last connection to the physical laws that once governed a younger, more energetic universe. In a sense, they'll become the universe's memory, preserving information about a time when stars shone and planets orbited, and life was possible. But this raises a question, one that strikes at the very heart of our understanding of existence. If black holes can survive the expansion and cooling of the universe, if they can continue to exist long after everything else has faded into darkness, then what does it mean for the universe to end? What does it mean for something to be eternal in a cosmos that had a beginning and seems to be heading toward a conclusion? The answer came from an unexpected source. Stephen Hawking, the brilliant theoretical physicist who spent his life grappling with the deepest mysteries of the cosmos. In 1974, Hawking made a discovery that would fundamentally change how we understand black holes, and, by extension, the nature of reality itself. He discovered that black holes aren't completely black. They emit radiation. This might sound like a minor technical detail, but it's actually one of the most profound discoveries in the history of physics. Hawking. Radiation, as it came to be known, emerges from the quantum fluctuations that occur near the event horizon of a black hole. According to quantum mechanics, empty space isn't really empty. It's filled with pairs of virtual particles that pop into existence and then annihilate each other in fractions of a second. Near a black hole's event horizon, something remarkable happens. Sometimes, one particle from such a pair falls into the black hole, while the other escapes. The escaping particle becomes real, carrying away a tiny amount of energy and causing the black hole to slowly shrink. This discovery created a paradox that has haunted physicists for decades. If black holes emit radiation, then they must eventually evaporate completely. But this evaporation process is unimaginably slow. A black hole with the mass of our Sun would take longer than 10 or 67 years to evaporate, a time span so vast that it makes the current age of the universe look like a brief moment. A supermassive black hole would take even longer, requiring more than 100 years to fade away completely. These numbers are so large, they're almost meaningless. To put it in perspective, the universe is currently only about 1.4 x 10 10 years old. The time it would take for a solar mass black hole to evaporate is longer than the current age of the universe, by a factor of 10 to the 57. That's like comparing a single second to a time span longer than the age of the universe, multiplied by itself, billions of times over. But here's where the story becomes truly disturbing. If black holes do eventually evaporate, then they're not truly eternal. They're just very, very long-lived. This means that even these cosmic monsters, these seemingly permanent features of the universe, are ultimately temporary. They're just another form of matter and energy, subject to the same laws of thermodynamics that govern everything else in the cosmos. Or are they? The more physicists have studied Hawking radiation, the more mysterious it has become. The radiation that emerges from a black hole appears to be completely random, carrying no information about what fell into the black hole in the first place. This creates what's known as the black hole information paradox. If information can never be destroyed, and quantum mechanics insists that it can't, then where does all the information that falls into a black hole go? Some physicists believe the information is encoded in the Hawking radiation itself, but in a way that's so scrambled and complex that it's impossible to decode. Others suggest that the information is stored on the event horizon, holographically encoded in a two-dimensional surface that somehow contains all the information about the three-dimensional interior. Still others propose that the information is transferred to alternate universes or parallel dimensions that we can't access. But perhaps the most radical possibility is that black holes don't actually evaporate at all. Perhaps Hawking radiation is just the beginning of a story that ends somewhere completely different. Perhaps black holes, when they reach a certain point in their evolution, don't disappear. They transform into something else entirely, something that exists outside our normal concepts of space and time. Something that preserves not just information, but the very essence of what it means to exist. This possibility is supported by some of the most cutting-edge theories. In modern physics, string theory, for example, suggests that black holes might be connected to other universes through wormholes, tunnels through space-time, that allow information and energy to flow between different regions of the cosmic multiverse. If this is true, then black holes aren't destroyers of information. They're cosmic transfer stations, moving the contents of our universe to other realities that exist beyond our ability to observe or understand. Loop quantum gravity, another approach to understanding the intersection of quantum mechanics and general relativity, suggests that black holes might undergo a kind of quantum bounce. When they reach a certain critical density, instead of collapsing to a singularity, they might explode outward, creating new universes in the process. In this scenario, black holes aren't the end of the story. They're the beginning of new stories, cosmic seeds, that give birth to entirely new realities. But even these radical possibilities don't address the deepest mystery of all, the nature of time itself. Inside a black hole. According to general relativity, time dilation near a black hole approaches infinity as you approach the event horizon. This means processes that would take finite time in the outside universe might take infinite time from the perspective of the black hole itself. In other words, a black hole might experience eternal time, even as the outside universe ages and dies around it. This creates a scenario that's almost too strange to contemplate. Imagine you could somehow survive inside a black hole, protected from the crushing gravitational forces and the breakdown of space-time. From your perspective, you might experience an infinite amount of time, watching the entire future history of the universe unfold in fast forward. As you fall toward the singularity, you might see the last stars burn out, the last black holes evaporate, and the universe itself fade into darkness, all while you're still falling, still experiencing the passage of time, still existing in a state that defies every law of physics you thought you understood. But this raises another question, one that's even more unsettling. If time flows differently inside a black hole, if the very concept of when becomes meaningless at the event horizon, then what does it mean to ask whether black holes will survive? The end of the universe, the question assumes that there's a universal timeline, a cosmic clock that ticks away the moments until everything ends. But what if that assumption is wrong? What if time itself is more fluid, more relative, more dependent on perspective than we've ever imagined? The answer might lie in a discovery that has emerged from the intersection of quantum mechanics and general relativity, the holographic principle. This principle suggests that all the information contained in a volume of space can be encoded on its boundary. In the case of a black hole, this means that everything that falls into the black hole, every atom, every bit of information, every moment of history, might be preserved on the event horizon itself, encoded in a two-dimensional surface that somehow contains infinite information. If this is true, then black holes aren't just survivors of the universe's expansion. They're the universe's memory. They're cosmic libraries that preserve not just information, but the very structure of reality itself. They exist in a state that's neither fully inside our universe, nor completely outside it, maintaining a connection to the physical laws that govern existence, while simultaneously transcending those laws. This possibility transforms the question of whether black holes will survive the end of the universe into something far more profound. A question about the nature of existence itself, about whether ending is even a meaningful concept. When applied to objects that exist at the intersection of time and eternity, space and infinity, the known and the unknowable, the mystery deepens with each new discovery, each new theory, each new glimpse into the cosmic abyss. Black holes aren't just objects in space, they're doorways to a deeper understanding of what it means to exist, to persist, to survive. In a universe that seems determined to erase every trace of its own history, they're the universe's way of asking the ultimate question: what happens when forever meets infinity? And both discover they're not nearly as permanent as they thought. Stop for a moment. Put down whatever you're holding. Feel your heartbeat. Feel the air entering your lungs, the weight of your body against the chair, the solid ground beneath your feet. Feel the reassuring solidity of the world around you, the walls, the ceiling, the familiar objects that define your everyday existence. Hold on to that feeling. Because what you're about to confront will shake every assumption you've ever made about what it means to be real, to be alive, to be anything at all. Everything you just learned about black holes, the warping of space-time, the breakdown of causality, the paradox of eternal persistence, it isn't just abstract physics happening in some distant corner of the universe. It's happening right now, in your galaxy, in your cosmic neighborhood. There's a supermassive black hole at the center of the Milky Way, just 26,000 light-years away. So massive, it could swallow our entire solar system and barely notice. And it's not just sitting there passively. It's actively shaping the motion of every star in our galaxy, including our Sun. The very orbit that Earth follows around the Sun is influenced by the gravitational pull of this cosmic monster. But that's not the part that should terrify you. The part that should keep you awake at night is this: if black holes exist in a state where time and space lose their meaning, if they preserve information in ways that transcend our understanding of physics, then every moment of your life, every thought, every decision, every heartbeat might already be encoded in the event horizon of a black hole. Somewhere in the universe, your entire existence might be nothing more than information, stored in a cosmic library that exists outside of time itself. Think about what that means if the holographic principle is correct. If all the information in a volume of space is encoded on its boundary, then you, your consciousness, your memories, your deepest thoughts and fears might exist simultaneously, in multiple forms. You might be living your life as a collection of atoms and molecules, moving through three-dimensional space, but you might also exist as patterns of information encoded on the two-dimensional surface of a black hole's event horizon. Which version is real? Which version is you? The answer is both and neither, and that is what makes this discovery so profoundly unsettling. You're not just a temporary arrangement of matter that will eventually decay and return to dust. You're also a pattern of information that might persist long after your physical body has crumbled, long after the sun has burned out, long after the galaxy itself has been torn apart by the expansion of space. You might be immortal in ways you never imagined, but that immortality comes with a price: the complete dissolution of everything you think you know, about identity, about consciousness, about existence itself. But even this isn't the deepest horror. The deepest horror is what happens when you realize the universe isn't just expanding, it's accelerating its own destruction. Dark energy, that mysterious force tearing space apart from the inside out, is getting stronger. The expansion of the universe is speeding up. Galaxies are being carried away from each other at ever-increasing speeds, disappearing beyond event horizons that we will never be able to cross. In a very real sense, the observable universe is shrinking, even as the actual universe grows larger. This means we're living in a cosmic bubble. That's getting smaller every day. The furthest galaxies we can see today will be invisible tomorrow. The cosmic microwave background radiation, the afterglow of the Big Bang itself, is being redshifted into oblivion. We're not just witnesses to the universe's expansion. We're prisoners of it, trapped in an ever-shrinking bubble of observability, while the rest of reality races away from us, faster than the speed of light. And here's the part that will make you question everything you've ever believed about purpose and meaning. This process is irreversible. There's no going back. There's no way to stop the acceleration, no way to prevent the universe from tearing itself apart. We're riding a wave of expansion that will carry us into a future so dark and so cold. It defies human comprehension. In a few billion years, alien astronomers, if they exist, will look out into the night sky and see nothing but the local group of galaxies. They'll have no way of knowing that the universe was once filled with billions of other galaxies. No way of discovering the cosmic microwave background. No way of figuring out that the universe had a beginning. They'll be cosmically alone, cut off from the very evidence that would allow them to understand their own existence. But we're not just passive observers of this cosmic tragedy. We're active participants in it. Every photon of light that reaches our telescopes has been traveling through expanding space for billions of years, carrying information about distant galaxies and ancient events. That information is precious beyond measure. It's the only window we have into the deep structure of reality itself. But it's also finite. Once those photons reach us, once we've observed the distant galaxies and measured the cosmic microwave background, that information begins to fade. The universe is showing us its secrets, but only once. We're living in the brief window of cosmic time, when the universe is old enough to have developed structures like galaxies and stars, but young enough that we can still see the evidence of its own origin. This creates a responsibility that's both overwhelming and terrifying. We might be the only conscious beings in the universe capable of understanding the big picture, of seeing the cosmic story in its entirety. We might be the universe's way of knowing itself, of understanding its own nature and destiny, but we're also temporary. We're fragile. We're utterly dependent on conditions that are rapidly changing as the universe expands and cools around us. And if black holes do survive the end of everything, if they do preserve information in ways that transcend space and time, then they might be the universe's way of ensuring that the story doesn't end with us. They might be cosmic time capsules, preserving not just information, but consciousness itself, allowing the universe to remember what it was like to be alive, to be aware, to be capable of wonder and terror and awe. The question is no longer whether black holes will survive the end of the universe. The question is whether we will survive long enough. To understand what survival even means in a cosmos where time and space lose their meaning, where information becomes more fundamental than matter, where the boundary between existence and non-existence dissolves into something that we don't have words for. Yet, you are not just a collection of atoms arranged in a pattern that happens to be conscious. You are a cosmic phenomenon, a way for the universe to experience itself. A temporary focus of matter and energy that somehow generates thoughts and feelings and the capacity for wonder. And if the black holes do preserve information, if they do maintain some connection to the deeper structure of reality, then some version of you might persist long after your physical body has returned to dust. The universe is vast, ancient, and utterly indifferent to human concerns, but it has given birth to consciousness, to the capacity for understanding, to beings capable of contemplating their own existence and the nature of reality itself. And now, through black holes, it might have found a way to make that consciousness permanent, to preserve the spark of awareness that allows the cosmos to know itself. The stakes couldn't be higher, the mystery couldn't be deeper, and the answer, when it finally comes, will change everything you think you know about what it means to be alive in a universe that seems determined to erase every trace of its own existence. Here it is, the moment when everything you thought you understood about black holes, about the universe, about existence itself, collapses into a revelation so profound that it will haunt you forever. Because what if I told you that the question we've been asking, whether black holes will survive the end of the universe, is backwards? What if the real question isn't whether they'll survive the end, but whether they're the reason the universe exists in the first place? Picture this. It's 100 years in the future. The last black hole in the universe is finally evaporating. Its Hawking radiation slowly bleeds away the final traces of mass and energy into the cold, dark void. This is the moment physicists call the ultimate heat death, when entropy reaches its maximum, when no more work can be done, when the universe settles into perfect, eternal equilibrium. The temperature everywhere approaches absolute zero. Space expands into infinite emptiness. Time loses all meaning because nothing changes, nothing moves, nothing happens. This should be the end of the story. But then, something impossible occurs. As the last black hole evaporates, as the final photon of Hawking radiation disappears into the cosmic darkness, the fabric of space-time itself begins to fluctuate. Quantum mechanics, which never truly goes away, even in the deepest cold of space, begins to assert itself on cosmic scales, and in those quantum fluctuations, in those random bubbles of possibility that emerge from pure nothingness. Something extraordinary happens. A new universe begins to form. This isn't just science fiction. It's the logical conclusion of quantum field theory. Applied to cosmology, even in empty space, even in the perfect vacuum of a dead universe, quantum fluctuations continue to occur. And while most are tiny and short-lived, Occasionally, very, very occasionally, a fluctuation is large enough and long-lived enough to trigger something called false vacuum decay. The vacuum itself becomes unstable and transitions to a lower energy state, releasing enormous amounts of energy in the process. Enough energy to create space, time, matter, radiation. Enough energy to create. A Big Bang. This means the death of our universe might not be an ending at all. It might be a transformation, a metamorphosis into something new and unimaginable. The black holes we thought were the final survivors might actually be the universe's way of ensuring its own rebirth. They might be cosmic wombs, preserving the information and energy necessary for the next iteration of reality to emerge from the quantum foam. But here's where the revelation becomes truly mind-bending. If this process can happen once, it can happen infinite times. Our universe might be just one in an endless chain of cosmic rebirths, each one emerging from the quantum remnants of the one before. The Big Bang that created our reality might have been triggered by the death of a previous universe, and our eventual death might trigger the birth of the next one. We're not living in the universe, we're living in a universe, one of countless iterations in an eternal cycle of cosmic death and rebirth. And those black holes, they're not just objects within this cosmic cycle. They might be the mechanism that makes the cycle possible. Every time a black hole forms, it creates a region where the normal laws of physics break down, where quantum effects are amplified, where the boundary between existence and non-existence becomes permeable. They're not destroying information, they're processing it, transforming it, preparing it for the next iteration of reality. This possibility is supported by some of the most cutting-edge theories in modern cosmology. Cosmic inflation suggests our observable universe is just one tiny bubble in an infinite cosmic foam, where new universes are constantly being born from quantum fluctuations in the vacuum. String theory proposes that what we call particles are actually vibrating strings in higher dimensional space, and that black holes might be portals connecting different regions of this higher dimensional reality. Loop quantum cosmology suggests the Big Bang wasn't the beginning of time, but the bounce that followed the collapse of a previous universe. But perhaps the most disturbing possibility is this: if the universe undergoes infinite cycles of death and rebirth, if black holes preserve and process information across these cosmic generations, then everything that has ever happened might happen again. Not similar things, the exact same things. Every star that has ever formed will form again. Every planet that has ever existed will exist again. Every life that has ever been lived will be lived again, down to the smallest detail. This means you, sitting here right now, reading these words, feeling whatever emotions are flowing through your consciousness, might have existed before. Not just once, but infinite times, and you will exist again, infinite times more, in future iterations of the universe, so far in the future that the very concept of time loses meaning. Your consciousness, your memories, your deepest thoughts and fears might be eternal. Not because they're preserved in some cosmic afterlife, but because they're part of a pattern that the universe is doomed to repeat. Forever, the black holes aren't just witnesses to this cosmic recycling. They're the librarians, the custodians, the guardians of continuity across infinite cycles of creation and destruction. They exist in a state that transcends individual universes, maintaining their grip on reality. As space and time are born, evolve, and die around them. They are the universe's way of ensuring that nothing is ever truly lost, that every moment of beauty and terror and wonder is preserved somewhere in the cosmic archive. Stand outside on a clear night. Look up at the stars, those points of light scattered across the darkness. Like diamonds on velvet, they are not just distant suns, they are the visible remnants of cosmic cycles that stretch back through unimaginable eons. Some of those stars might have formed from the ashes of previous universes. Their light, carrying information about realities that died and were reborn before our cosmos even began to exist. And somewhere out there, hidden in the darkness between the stars, are the black holes, ancient, patient, eternal. They've seen universes born and die. They've watched the cosmic wheel turn. Through countless iterations, they know secrets about the nature of existence that we're only beginning to glimpse. They are the universe's memory, its conscience, its promise, that even when everything ends, something will remain to carry the story forward into the next chapter of the infinite book of reality. The question isn't whether black holes will survive the end of the universe. The question is whether the universe, as we understand it, is capable of truly ending at all. Because if the black holes are right, if they are the guardians of cosmic continuity, then what we call the end might just be another beginning in disguise. The universe might be like a phoenix, burning itself to ashes, only to rise again. From the quantum flames, stronger and stranger than before, and in that endless cycle of death and rebirth, in that eternal dance of creation and destruction, you are not just a temporary arrangement of atoms, destined for oblivion. You are a note in the universe's infinite symphony, a verse in its endless poem, a character in its eternal story. You have always existed, and you will always exist, playing your part in the cosmic drama that unfolds across scales of time and space, that dwarf human comprehension. The black holes know this. They've been waiting, watching, preserving, and when the last star burns out, and the universe grows cold and dark, they'll still be there, ready to midwife the birth of whatever comes next. Because in a cosmos where information can never be destroyed, where consciousness might be more fundamental than matter, where time itself might be cyclical rather than linear, the end is never really the end. It's just another beginning, waiting to be born from the quantum darkness of eternity. You came here asking whether black holes will survive the end of the universe, but somewhere along this cosmic journey, the question transformed into something far more profound. You've discovered that the universe isn't just a collection of matter and energy scattered through empty space. It's a living, breathing entity, constantly reinventing itself, constantly finding new ways to preserve the spark of consciousness. That allows it to know itself. And black holes, they're not just cosmic monsters, devouring everything in their path. They're the universe's memory banks, its guardians of continuity, its promise that nothing truly important is ever lost. But we've only scratched the surface of this cosmic mystery. Every answer we've uncovered has raised 10 new questions, each more unsettling and more beautiful than the last. We've glimpsed the possibility that our universe might be just one note in an infinite symphony of creation and destruction. One chapter in an endless book of reality that's been writing itself across scales of time that make eternity look like a fleeting moment we've seen. That consciousness itself might be more fundamental than the atoms and molecules that seem to generate it, that your thoughts and memories and deepest experiences might be woven into the very fabric of space-time itself. Think about where you were when you started reading this story. You probably thought you lived in a universe with clear boundaries, a beginning, a middle, an eventual end. You probably believed that when you die, when your brain stops functioning and your body returns to dust, that would be the absolute conclusion of your existence. You probably assumed that the universe was a stage where the drama of life unfolds, but not a participant in that drama itself. Now, look where you are. You've discovered that the universe might be immortal, cycling through infinite iterations. Of death and rebirth, you've learned that your consciousness might be preserved in ways that transcend physical death, encoded in the quantum structure of reality itself. You've seen that the very question of survival, whether for black holes, for human beings, or for the cosmos as a whole, might be based on assumptions about time and identity that are far more fragile than we ever imagined. But this is just the beginning right now. As you read these words, telescopes are peering deeper into space than ever before, revealing new mysteries about the nature of black holes and the structure of reality. The James Webb Space Telescope is showing us galaxies that existed when the universe was just a few 100 million years old, revealing how the first black holes formed and grew. Gravitational wave detectors are listening to the cosmic symphony of black hole mergers, giving us new insights into how these objects behave when they collide and combine. Quantum computers are beginning to simulate the physics of black hole interiors, potentially revealing secrets about what happens beyond the event horizon. Every new discovery brings us closer to understanding the deepest questions about existence itself, but each answer also reveals new layers of mystery, new paradoxes that challenge everything we thought we knew about the cosmos. We are living in the golden age of cosmology, when human beings are finally developing the tools and techniques to probe the fundamental nature of reality. But we're also living in a time of unprecedented cosmic mystery, when every answer seems to lead to 10 new questions, and that's where you come in. This isn't just a story you've read, it's an invitation to join the greatest adventure in human history, the quest to understand the cosmos, to grapple with the deepest questions about existence, to push the boundaries of what's possible for conscious beings, to know about their own reality. You don't need a PhD in physics. You don't need billion-dollar telescopes or particle accelerators. You just need curiosity, wonder, and the courage to confront questions that have no easy answers. Start by looking up at the night sky. Those stars you see, they're not just distant points of light. They're nuclear furnaces, actively creating the elements necessary for life. Consciousness and thought. Some of them will eventually collapse into black holes, joining the cosmic community of objects that exist at the intersection of the known and the unknowable. Others will explode as supernovae, seeding space with heavy elements that will eventually form new stars, new planets, and perhaps new forms of life. But don't just look, think, wonder, question. What does it mean that you, a collection of atoms, forged in the hearts of ancient stars, can contemplate the nature of black holes and the fate of the universe? What does it mean that the cosmos has evolved? Conscious beings capable of understanding their own cosmic context? What does it mean that the universe might be cyclic? That your thoughts and experiences might be part of an eternal pattern that repeats across infinite iterations of reality? These aren't just abstract philosophical questions. They're practical challenges that will shape the future of human civilization. Because if black holes really do preserve information across cosmic cycles, then everything we do, everything we create, everything we discover might have permanent significance on cosmic scales. The art we make, the knowledge we gain, the love we share, all of it might be woven into the fabric of reality itself, preserved in quantum patterns that will outlast the death of stars and the expansion of space. This gives our brief moment of cosmic consciousness unprecedented importance. We're not just temporary arrangements of matter. We're the universe's way of understanding itself, of grappling with its own nature and destiny. We're cosmic archaeologists, uncovering the secrets of reality itself. We're cosmic artists, creating beauty and meaning in a cosmos that might otherwise be nothing but matter and energy, following mathematical laws. But we're also cosmic children, just beginning to understand the true scope and nature of our cosmic home. We've learned enough to know the universe is far stranger and more wonderful than our ancestors ever imagined. But we've barely begun to grasp the implications of what we've discovered. We know that black holes exist, but we don't know what exists inside them. We know the universe is expanding, but we don't know why or what it's expanding into. We know that consciousness emerges from matter, but we don't know how or why or what it ultimately means. These mysteries aren't obstacles to overcome. They're invitations to continue the journey. They're reminders that the universe still has secrets to reveal, still has stories to tell, still has wonders that lie beyond our current understanding. And every time we push a little further, every time we ask a new question or make a new observation, we participate in the cosmic conversation. That's been going on for 13.8 billion years. So here's your challenge. Don't let this story end here. Take these questions with you into your daily life. Share them. Wonder about them. Let them change how you see yourself and your place in the cosmos. Let them inspire you to learn more, to question more, to participate more fully in the greatest mystery story ever told. Because the universe isn't just something that exists around you, it's something you're actively participating in, helping to create, contributing to, with every thought, every choice, every moment of consciousness. If black holes really are the universe's memory banks, if they do preserve information across cosmic cycles, then your participation in this cosmic conversation isn't temporary, it's eternal. The black holes are watching. They're waiting. They've seen civilizations rise and fall, stars be born and die, galaxies collide and merge and drift apart. They know secrets about the nature of existence that we're only beginning to glimpse. And maybe, just maybe, they're counting on us to figure out the next piece of the cosmic puzzle, to take the next step in the universe's journey toward understanding itself. The question isn't whether black holes will survive the end of the universe. The question is, will we survive long enough? As individuals, as a species, as conscious beings, to understand what survival really means. In a cosmos where time and space and identity are far more fluid than we ever imagined, the universe may be infinite. Its mysteries may be inexhaustible. Its cycles of death and rebirth may continue forever. But one thing is certain. Right now, in this moment, you are part of something vast and ancient and wonderful, beyond human comprehension. You are the universe, becoming aware of itself, asking questions about its own nature, marveling at its own beauty and strangeness and infinite complexity. The universe may have no end, but maybe, just maybe, neither do you.